This is section 3.2, the mean value theorem. And the first thing we're going to talk about is Rolle's theorem. And Rolle's theorem says if you have a function, and you can look at the three things that need to be true there, that f is continuous on a closed interval, differentiable on an open interval, and that f of a is equal to f of b. This says, in this case, there is a number c in that interval, a to b, with f prime of c equaling 0. So I want you to think about a couple different situations here. The most basic situation would be that, remember, f of a has to equal f of b. So I'm going to do that for each one of these three different examples here. But that's the key thing with Rolle's, is that f of a has to equal f of b. And it says as long as you are continuous and differentiable on that interval, then you're going to have a place where the derivative is equal to 0. So the most basic example would actually be a constant function. And you can see that if you had a function that was constant from a to b, every single value that you could pick between a and b would have a derivative of 0, because it's a constant function, and so its derivative is always 0. Now, any other situation you have would require the function doing something between a and b. But you can see that in a case like this, if the function, say, goes up and then comes back down to get back to, remember f of a has to equal f of b, you're going to have that same idea where there is going to be a place where the derivative is equal to 0, where you have a horizontal tangent line. So that's another example. And there's also, an infinite number of examples. You could have a function that comes up, goes down, comes back up, and then in that case you might have a couple places, a couple values of quote-unquote c, where you have a horizontal tangent line where the derivative is equal to 0. But Rolle's theorem says that that thing must exist. So the proof of Rolle's theorem is that if you have, the first case would be the first picture that I showed. If f is a constant, if you have a function that is constant, then you can pick anything from a to b and your derivative is going to be 0. If, however, you have, say, f of x being greater than f of a, so you have your first value f of a, and say f of x, so some y value on the interval, is greater than f of a, then you're using the fact that the function is continuous and the extreme value theorem, which we talked about earlier in a previous section, that says that there must be a maximum. Remember, the extreme value theorem talks about maxes and mins. There is a maximum on that interval. Okay. However, since f of a equals f of b, this max must be somewhere in between f of a and f of b. It has to be in there somewhere. So it tells us that the function has a max at c, and f is also differentiable at c. And so that extreme value theorem tells us that f prime of c has to equal 0. And you could do almost the same exact proof if you just consider f of x being less than f of a. So the point being that there is some y value less than f of a, and then it has to come back up. So you must have a min, and due to the conditions that you have of continuity and having differentiability, that derivative there has to be a place where that derivative is equal to 0 as well. So that's all that Rolle's theorem tells us. And the idea here is, if I were to throw this up in the air, and I have to be a little bit careful, but my idea would be to throw it up in the air and catch this at the same height, you can see that there is a place where this stops going from up and comes back down, and at some spot there at its maximum, it's going to have a horizontal tangent line, and that derivative of that is going to be 0. So let's do example here of Rolle's theorem. So we have an equation. It's not particularly pretty, just in the fact that it has algebra and trig. So our job here is to show that it has exactly one real root. So there's only one place where, if you consider the function, so let's consider, oh, that's a t, let f of x equal 2x minus 1 minus sine x be, so we have this function now. And something that we've done already in the past is we've talked about this idea of saying that there is a root, and that's taking us back to our mean value theorem, or excuse me, intermediate value theorem. And so we want to be reminded that f of x is continuous because we have algebra, and then that trig sine of x is continuous, so f of x is continuous. And the reason is, as it is a sum of continuous functions. So what we know is that if we have functions that are continuous and then we add them together, they're still continuous, or subtract them together. So let f of x equal this function. Let's be reminded that for the intermediate value theorem, we just check what our y value is at our endpoints there, so 0 and 1. So if you do f of 0, you can pretty quickly see that 2 times 0 minus 1 minus sine 0 is going to be a negative 1. Key thing is that is less than 0. If you put in 1, you're going to have 1 minus sine of 1. So that's just putting in, if we put in 1, we get 2 times 1 minus 1, which is 1, minus sine of 1. And that is going to be, we know that sine of 1, we can, where's my calculator? Okay, got 8 work desks here. So if we do sine of 1, we just want to make sure that we are in radians. And we do sine of 1, and we get like 0.84 something, so 1 minus that. So this is going to give us some estimate. Point being it's positive, so 1/6, I'll just do 2 decimal places. This is greater than 0. Okay. So the point is, thus the intermediate value theorem, the IVT, tells us there is a root on the interval 0 to 1. Now, it's basically saying that there's at least, the IVT says at least one root. It really doesn't tell you how many you have. It just says, well, if the function is going to be down here and then it's going to be up here, it has to go through the x-axis. Now, it could be down here and be up here and still like do this, right? It could have like multiple roots. You don't know just from the IVT how many roots there are. So now it says show that there can't be 2 roots. So maybe it'd be better to tell you at least 1 root there. So now show that there can't be 2 roots. So this is more about the idea of using Rolle's theorem here. So we're going to say if there are 2 roots, okay, so say there's 2 roots, so we're on the interval 0 to 1. I'm going to call the roots A and B. Okay. Understand that what that means is then f of A has to equal f of B, because if both A and B are roots, then f of A equals f of B, and because they have to have the same y value, because if they're roots, they have to their y value has to be 0. But it also tells us that f of A minus f of B has to equal 0. So f of A equals f of B, so f of A minus f of B has to equal 0. That's just subtraction. But remember, the function that we're talking about here is 2x minus 1 minus sine x. So we're thinking about this function. Now we've already found from the top part that f of x is continuous and differentiable everywhere. Because we can take derivatives and we are fine. Okay. So since we have the function being continuous and differential everywhere, we can now apply Rolle's theorem. So Rolle's theorem says that there is a number C on that interval, and actually we're going to do the interval between this R2, what we're claiming our two roots are, with f prime of C equaling 0. That's what Rolle's theorem says. But I want you to imagine we take our derivative. Take a look at the derivative here. The derivative of your function is 2, and then we're taking the derivative of sine x, so 2 minus cosine x is the derivative of our function. And what we know is that the idea of 2 minus cosine x equaling 0 tells us that cosine x, so if I subtract the 2 and then divide by -1, I get, it's the place where cosine x equals 2. All right, well, that is not possible due to the range of cosine. So what that tells us is there can't be two roots. So what we just found was that we're thinking about this interval, f of 0, f of 1. And we just said, okay, let's say that there are two roots. Okay, so it's essentially proof by contradiction. Let's say that we have these two roots where f of a equals f of b, they'd have to be 0. And let's say they exist. And if they exist, well, since the function is continuous, since the function is differentiable, Rolle's theorem tells us that to go from here to here, the function must do this, or the function must do this, if there were two roots. Now, in order for that to say Rolle's theorem is true, because it must be, we'd have to have a place where the derivative is equal to 0 here, or the derivative is equal to 0 here. However, by taking the derivative of our function, we can see that the place where the derivative would have to equal 0 would be where cosine of that value equals 2, and cosine of that value never equals 2. So therefore, there is not the possibility of having f of a equaling f of b. So there is, and thus there is no place where you could have two roots. So that is Rolle's theorem. For the second video, I'll do all the work for the mean value theorem, which is a very, very important theorem in calculus.